Sketch each of the following, stating their domain and range. And the first one we have is y is the modulus of x squared plus 3. The first thing to do here is think about it without the modulus. So let's make a sketch of that. So we've got y, we've got the x-axis here. And what I'm going to do is make a sketch lightly of the y equals x squared plus 3, which we know is a quadratic, like so, which intersects the y-axis at 3. It's x squared moved up by 3 units. Now, since we're doing the modulus, anything that's above the x-axis will stay the same, and anything below the axis will be reflected back up above. In this case, our entire curve is above the x-axis. So in other words, the modulus of x squared plus 3 is exactly the same as y equals x squared plus 3. So this is the graph of y equals mod x squared plus 3. The domain, well, there's no problem with any real values, so the domain is just all reals. And the range, well, we can see there's no graph down here, and it starts at 3, and then will go on forever. So y is a real, but only greater than or equal to 3. So now let's look at the next one, modulus x plus 1, x minus 2. Let's think of it without the modulus. So if I just expand it as well, I get x squared minus x minus 2. So let's have our axes. So y-axis and the x-axis. And once again, let's make a light sketch of that one. So we know that the intercepts would be at -1 and at 2. And because the x squared coefficient is positive, it's a happy curve. So it's going to look something like this. And we know that the y-intercept here is at -2. We can see that from here. Now for the modulus, we know that a modulus doesn't output any negatives. So the part that's below the axis is going to reflect up above, like so. So it will intercept here at 2. But the parts that are above the axis will be returned just as they are. So it's going to look like that. So that is the modulus of x plus 1, x minus 2. Again, with the domain, there's no problem with any x value. For the range, we can see that it does come down to the axis here and here. So we get y is a real greater than or equal to 0. Finally, we have y equals the modulus of tan x. Now, obviously, tan x goes to negative infinity and infinity in both directions. We can't draw every single limb of it. So we're first going to consider y equals tan x. Now, let's maybe do a section that goes from -180 to 180. So if I have -180 here, that's in degrees obviously, so I should change that. Let's do it in radians. So we'll go -pi, and so we'll have -pi by 2 here. 0 obviously at the origin. Let's make this pi by 2, and let's make this pi. And then we'll draw in the tangent again lightly, and we'll go over it where we need to. So We know that there is an asymptote at negative pi by 2, like so. And the tangent comes up, goes through the origin, it's got a point of inflection there, not horizontal. And goes off like that. Then the beginning of this limb is like that. And this one goes from here up like that. For the modulus, what are we going to have? Anything that is above the axis will stay the same. The parts that are below will reflect upwards, like so. So what about the domain? Well, we know that it can't take odd multiples of pi by 2. The next asymptote along here would be at 3 pi by 2. Next one that way would be negative 3 pi by 2. Then we've got asymptotes at 5 pi by 2 and so on. So we could say it's reals, but x cannot be equal to an odd multiple of pi by 2. We need to qualify there that n is an integer. What about the range? Well, we can see that it comes down to the axis and then will go up forever. So we get y is a real, y is greater than or equal to 0.